Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give you some examples that demonstrate how the rules given here can be implemented. Okay, so these are the rules which you have already seen in the previous video, and we are going to implement them in solving these examples here. So for question A, you are asked to find the derivative of this function when you have x to the power of 2000. So this is the function given here. And dx, so here is the function. And the answer to this is going to be 2000 right next to x. This one is 2000 minus 1. And so this will become 2000x 1999. So this answer is obtained by applying rule number 2. Okay. Next is the second question. This is the differentiation operator where it is interested, or it is asking you to find the derivative of this function with respect to v. So you're going to differentiate this function with respect to v. And here we have d dv for v and m. So here, first of all, you recognize that this is a constant and you can take it out. So we have 4, then vm. So this is applying rule number 3. Okay, rule number 3, you take out the constant, and then you focus on finding the derivative of this function. And the result here is going to be m times with v m minus 1. And this is by applying rule number 2. And this can be just simplified as such. Okay. Okay, next is question C. So here we have hx, and you can see that this is the multiplication process here. So you can consider this function to be perhaps fx and this function as gx. And so hx is made of multiplying the two functions together. So now what I'm going to do is I'm going to apply in order to find h prime x, the derivative of this function, we can apply the following formula, which is fg prime plus gf prime. So here f is going to be maintained as it is. So here we have f, so it's going to be 6x cubed, and we are going to find the derivative of g. So this is g prime, the derivative of it is going to be 7 for x cubed. Sorry, 7 for x cubed, that's right. Next, plus g is going to be maintained, so g is 7x to the power of 4. And if you differentiate this function f, what you will get is 3x squared. And then you can simplify the expression here. So here we have 6 times 28 is 168 x to the power of 6 plus, so here we have 7 times 18, so that is 126, and here we have x to the power of 6, and we know that we have the similar terms and you just can add them up together. So plus 168 and 126, it's going to be 294 x to the power of 6. So that's the solution for question C. And of course, this question can also be solved easily if you consider simplifying the expression in the first place. So here, if you have hx is equal to 6 times 7 is 42 x to the power of 7. And so if you differentiate this function, you will get 42 7 x to the power of 6. And 42 times 7 is going to be equal to 294 x to the power of 6. So the answer here is similar to the one obtained here. Okay, Right, so I'm going to erase the ink on this slide and continue with the next question. Okay, so this question here will not be done yet because you need the knowledge from section 3.5. So once you have understood what's going on in section 3.5, you can go back to answering this question. Just note that this example here has already been solved. This is the same example as in example 3.4, and in example 3.4 we have solved this exact question using the definition of derivative, which means using this definition, f prime x is equal to limit h approaches 0 fx plus h minus fx over h. So that is what you have already done in example 3.4. You have obtained the answer, and now later on, once you are done with section 3.5, you can go back to this example and try to solve it again. Okay, so this is not going to be covered in this video. Move on to the next question here, which is this question. So notice that this is the same exact question as given in example 3.3, and you have solved this question. You have found the derivative of this function using the definition or implementing the idea of limits, which is f prime x limit h approaches 0 fx plus h minus fx over h, and you have managed to get the answer. So you can refer back to example 3.3 for further details. And in this video, I'm going to show you how to get the derivative of this function using the simple rules that we have shown you just now. Okay, right, so now this is my function. I'm going to call this function hx so that it doesn't confuse with the notation that I'm going to use next. So I'm going to call this function hx is equal to 1 minus x over 2 plus x, and I'm going to change it to finding h prime x. So here I'm going to call this part as fx and this part as gx. Okay, and in order to find h prime x, I can apply the formula. Okay, so how to find h prime x? H prime x can be found by applying this formula, g f prime minus f g prime over g squared. So here we have g is a function that is going to be maintained, so that is 2 plus x. Next, if you differentiate f prime, you will get that this one, if you differentiate constant, it will be 0, and you differentiate this is going to be equal to negative 1, minus f is 1 minus x, and g prime is going to be equal to 1. Okay, because this is a constant, you differentiate constant, you get 0, and this one is equal to 1. And here g squared is 2 plus x squared, and we're going to simplify the numerator part, so it will be negative 2 negative x, and then here we have negative 1 plus x over 2 plus x squared, and then positive x can be cancelled with negative x, so the final answer is going to be negative 3 2 plus x squared. Okay, and this is the same answer which you have already obtained in example 3.3 using this approach. Okay, all right, that's all for now. Thank you very much for watching.